First off, once again, thanks for spending a bit of your Friday with us here. We're excited to have the opportunity to talk to you about some work that we've done here at Strasz Assessment Systems, along with AAMC and ACS Ventures in this area of applying AI to the test development process, and in particular, looking to create efficiencies through that process through the use of technology. I am Dr. Rory McCorkle. I work at Strasz as our VP of Business Development, and know a number of you from around the industry. So again, it's really great to have you all here today. One quick reminder, this is being done via Zoom's webinar function. So for those who have not dealt with that before, there is the ability for you to ask questions via the Q&A function as well as the chat function. So please, as you have questions during the session, feel free to pop those in there. I'll be monitoring that as we go to ensure that we get any questions you have answered during the session. If it's something that we cannot answer, we'll look to do that after the fact. So again, feel free to plug those in. We really appreciate it. We're going to get started with some quick introductions here before we launch in and start talking first about automated enemy identification. So with that, pleased to have Dr. Susan Davis-Becker on the line. Susan?
Hi, thanks everyone for joining us, and thank you to Roy and the team for inviting us to participate. Dr. Susan Davis-Becker, I'm a psychometrician and partner with ACS Ventures. So ACS has been around now since 2016. We support clients across the credentialing industry and do also some work in K through 12 as well. We do a lot of validity research, program and test design, and then test development and evaluation activities. We're a team of 12 psychometricians, assessment specialists, and program managers.
Thanks, Susan. And in addition to myself, I'm joined by Gary Spivack from our team. Gary?
Hi, everybody. I'm Gary Spivack. I'm the product owner here at Strasz Assessment Systems. I'm in charge for the evolution of the product suites that some of it will be showing you today. Started my career a long time ago at ETS and as a developer, and moved my way over into product ownership and project management.
Thanks, Gary. And just for anyone who's not familiar with Strasz, just wanted to give a couple quick lines about who we are and what we're about. The organization's been in place for over 2 decades now. We're a hair over 50 folks here, working remotely primarily, although we do have our primary office in central New Jersey. We're very blessed to have a really experienced team, as well as a team that is quite consistent. We have a very low turnover, which means that we're able to build up a lot of knowledge around both products, the assessment industry, and test development practices. Our key platforms involve Pro, which is our item banking and publishing system, which you'll see a little bit today. We also have platforms for exam delivery, which we call Test. SetScore, which is our collaborative platform for standard setting. And we also are a test delivery provider, delivering as a consolidator for Pearson VUE, as well as via remote proctoring. So all that said, we've spent quite a bit of time this year really investing in the central thesis of as a lot of the industry has looked at automated item generation, we wanted to spend quite a bit of effort and time looking at how AI can really power efficiencies in the test development lifecycle. And again, 2 of those efforts is what we'll go over today. All of this certainly would not be possible without a great collaboration and ongoing partnership with Marc, Erica, and AMC. So I'll turn it over to both of you.
Good afternoon, good morning, everyone. My name is Marc Kroopnick. I am the Director of Test Development and Psychometrics at the Association of American Medical Colleges. I am pleased to be here today with my colleague, Erica Rutzler, who oversees development, publishing, and science education for the medical college admission test. Would like to tell you a little bit about the AAMC, the Association of American Medical Colleges. We represent medical schools, teaching hospitals, health systems, academic societies. Our vision is very aspirational, as most visions are, a healthier future through learning, discovery, healthcare, and community collaborations. We're getting there by leading and serving the academic medicine community to improve the health of people everywhere. One of the tools to that end is the medical college admission test, which was the motivation for some of this work today. Next slide. Next slide. So I do want to tell you a little bit about the exam. It is part of the holistic evaluation of applicants' academic readiness for medical school. It's required at all U.S. allopathic and many Canadian medical schools. And there's 4 sections to this exam. Each section, the title is a mouthful, so I won't try to say all 4 of them here. I'll let you read them. They do each have an acronym. But generally, 2 of the sections focus on the natural sciences. One section primarily focuses on the social sciences. And there's a 4th section that is very much like a verbal reasoning section. We call it the critical analysis and reasoning skills section. I bolded 2 sections there, one of our natural sciences sections, and then the other, our section that's primarily social sciences, because they were the focus of the proof of concept that Erica will discuss later on. I should note that each of these sections are primarily passage-based, which means the examinee will interact with a couple paragraphs and have 4 to 7 items based on that text. For the 3 science sections, we do also have some standalone test questions. So a little bit about how the exam is administered in any given testing year. We are an event-based testing program. We have over 30 events per year. We deliver the exam to over 100,000 examinees. It is a long test day, about 7 hours, inclusive of breaks. Each section being about an hour and a half of testing time. So as you can imagine, for a test administration design like this, for the number of examinees we are administering to, we need lots of test forms. In fact, each of these test sections are assembled independently. So we really are doing lots and lots and lots of form assembly every year. Let me share a little bit about what that looks like. Next slide. So we start with a custom mixed integer linear programming solution. It's an automated solution that gets us to the first draft. From there, all of our test forms are shared with our subject matter experts who are reviewing them for a couple of different things. First, as you can imagine, is technical accuracy, but also it's about evaluating the extent to which all the test questions get along. And that's where we're kind of looking at item enemies. And we've described these item enemies, 2 different flavors of item enemies. The first we're calling hard enemies, and that's when an item cues or clues another item. So for example, maybe a distractor in one question gives you a hint on what the key is on another question. So again, hard enemies, cueing, cluing, these items cannot be on the same test form. The other type of item enemy that we are looking for, we're calling soft enemies. There's really more of a balance or feel issue. So for example, maybe there's 2 standalone questions that are referencing the heart. We may flag that. and say, you know what, can one of them reference the liver instead, and work with our form assemblers to see if that could happen. So we are checking for these types of things in our form assembly process. Next slide. So as you can imagine, this evaluation is very labor intensive. If you just take a test section with 59 questions and 10 passages, that results in 2,346 pairwise comparisons. So that is the upper bound of kind of what our subject matter experts could be navigating. Now, in fairness, we have a passage-based design. Item development guidelines call for all of those items that are associated with a given passage to get along. So our number is not quite this big in terms of really what we are evaluating, but it gives you an order of magnitude. So you can see that, especially if a form happens to have lots of conflicts and enemies, this can be a very cognitively taxing effort for our subject matter experts. So you might say, well, why don't you just code all of this at item development? And so we don't have this problem downstream at form assembly. And that's just impractical for us, given the size of our item bank, given the amount that we field test each year. That is not practical. So we working through this effort at the form assembly stage to give our subject matter experts the cleanest, most enemy-free form we can after that first delivery. And we all know that if the first draft is cleaner, the entire process is so much easier. So we had to figure out a way to flag these item enemies. And so we are evaluating text similarity. And essentially what we need to do with text similarity is assign numbers to words. Assign numbers to the words. And across an item, those numbers become vectors of numbers. And we can compare vectors of numbers, one associated with each item. There were two ways that we decided or considered doing this, which I will talk about at a very, very high 25,000 foot view conceptual level for the purposes of this presentation. And the first way is bag of words. And I think that name is very illustrative of what's going on there. The algorithm, the methods for getting those numbers to words and vectors just considers the words. There's no technology to navigate synonyms. There's no technology to navigate context. You can do some things related to weighting. You can downweight really common words. You can ignore words. But this is really a comparison of words. And in complete transparency, that's where we started. And as you'll see in a couple slides, we weren't super impressed with that. We needed an alternative, one that could take into account synonyms, one that could consider context. And that's what led us to the large language model SBIRT, sentence bidirectional encodal representations, which for the purposes of this presentation is a large language model and can appreciate much more of what's going on in the context of our test questions. But at the end of the day, for both of these methods, next slide, the words in the items were transferred into vectors of numbers. Those vectors were compared, and they were compared via a cosine similarity indice, which can be interpreted very similarly to a Pearson correlation, where those values that are large in absolute value are indicating text similarity, potentially an item enemy. Those numbers that are small are indicating friends. Before I go on to the next slide, I do want to acknowledge a colleague, Jeff Dahlke at Humro, who did help with a lot of the thinking in this part of our work. So next slide. So I did spoil a little bit in indicating that we preferred, or we weren't super impressed with Bag of Words, and led ourselves down to using a large language model, SBERT specifically. And in these two evaluations, you will see why we landed there. So next slide. We were able to benefit from having an existing small data set of item enemies and friends from our MCAT work. And we applied both approaches to that sample of data. And next slide. And so you can see, you know, we had some known enemies, we had some known friends from our prior work, and here are the distributions of cosines. And you can see on your left, the Bag of Words methods, there's no separation there, right? That's what we saw first. We weren't really impressed with that. That wasn't going to be helpful. So SBERT, you see, there's some separation, there's some promise, there's some interest. We think it could help us. So we went with SBERT. Next slide. And we were able to leverage some artifacts of a prior form assembly effort where we could see what items stuck and stayed in a form, friends, which items were swapped out. Here, focusing on our hard enemies, were swapped out by our content editors. And you can see we had many friends pairs and you know, a good number of enemy pairs. And next slide shows the results. And here we also are seeing some separation. That red line is the cosine similarity index distribution for enemies, the green line for friends. There was promise here. We thought that, okay, SBERT, the large language model, is giving us some good signals of what may or may not get along. And so we decided to work with our colleagues at Strasz to see if we can implement this into our form assembly process, so we could get this signal ahead of sharing a form with our content experts at form review. And I think at this point I transfer the presentation to Rory.
Thanks, Marc. And I was just chuckling throughout your commentary there, watching Susan's eyes light up when we put out a formula. I'm like, I know this has to be making psychometrician hearts rejoice here. But when we began this process of integrating and looking at developing this automated enemy identification process, there were a few considerations that we had. Both with respect to how we were going to configure this and also the options that we were going to provide to users through this process. Couple things to mention with regard to how that was done. So first off, within our pro item banking system, we have this concept of pool books. Pool books for us can be draft forms, they can be a collection of items set aside for a designated purpose. Again, it's a flexible concept, but really had to look at, you know, really where we were going to embed this item analysis process to best support the way in which it was going to be used for item identification. So first off, we felt that the pool book stage was the best place to put the feature, both for the ability of organizations to assess draft forms, as you've heard from Marc, and do that at the exam assembly process. It also gives the ability, if there's organizations who, for example, maybe have a smaller item bank, they could look at their entirety of their item bank within a pool book for potential enemy item status, and again, use that function to do so. Basically, what we do is via Pro, we have a plugged-in secured API that goes to the large language model and requests back data from that, doing all of the varied pairwise comparisons that you've heard Marc mention. We do have that customized because, as Marc pointed out, different groups have different types of items and configuration that lend to one approach versus another. So, for example, we do give users the options to customize what text they want analyzed for enemy item purposes. Is this going to be comparing passages in addition to items? So again, whether that feature is selected and compared. Is it simply the items themselves? Do you want to skip looking at distractors, depending upon the nature of how your examination is developed? Similarly, do you want to skip cloned items or sibling items that are identified? All of those are configuration options that are selected and built into the customization for the analysis. And this allows ultimately for again, adaptation of how you want to look at your content for this automated analysis. And as we'll talk about in a minute with Erica, there's always going to be some degree of false positives, false negatives. So again, trying to look at what customizations might be best to limit those. Within the system, we've also allowed for selection of different models. Espert is one of those, but again, there's alternatives that can also be selected. As mentioned by Marc, it was an important consideration for us to look at where this was going to occur. And as you heard, we did find amongst our client base, not just AAMC, but amongst others, that test assembly process appeared to be the most logical. Did not find a lot of organizations doing an item bank analysis looking for this in the manner in which Marc said would be impractical for AMC. So again, that also aligned well with their pilot. And then the final consideration, and certainly something that our technology group spent quite a bit of time on, is infrastructure. As we will talk about with both this feature as well as automated test assembly, this is a resource demanding process and certainly requires quite a bit of computing power given the number of comparisons generated and, in essence, the lines of code analysis that are created through this process. So accordingly, that meant that we needed to do some upgrades, in particular, adding GPU chips into our infrastructure to be able to accommodate that larger scale analysis and infrastructure needs. So with both the configuration options thought out, the development thought out, and then finally the supporting infrastructure done, I'm going to turn it over to Erica to talk about how the results played out for the pilot, and then right after that, we'll get a quick demo from Gary. Erica.
Thanks, Rory. So what we did once we did the research outside of the item bank, and then Strasz built a new feature for us, is we applied that model to the 2023 field test items for two sections, CPBS and PSPB. What we then did is, with the help of SMEs, we evaluated 50 content pairs with the largest index values, meaning we thought they'd be enemies, and 50 content pairs with the smallest index values, meaning they'd be suspected friends. The results were very good when comparing the model with what the SMEs found. 100% of suspected friends were confirmed friends in CPBS, and 95% of suspected enemies were confirmed as such as well. And in PSBB, we had similar numbers. 95% were friends, and 92% of the suspected enemies were enemies. For both the sections, the enemy content pairs investigated did not include passages, which is a good thing. The top 50, there were no passage to passage, there were no passage comparisons with numbers that high, which boasts to our content development, where passages aren't written or designed to include testable content, so they shouldn't really be enemies of each other. So it shows that we're doing a good job with that. The next slide, please. The next thing we did is we took 10 forms from 2024 that were evaluated, finalized, enemy-free. They were looked over by the SMEs and delivered in 2024. For both sections, over 90% of the index values were below 0.6, which gave us an idea of where we might start looking to come up with an area where we might start to see more enemies and such. Next slide, please. So we have some future plans. Initially, we after we went through the 2024 forms, we did some index value pairs between 0.6 and 0.7. And we found that between 80 and 90% of them were friends. So we know we wanted to do the next step, which is to look at the content between 0.7 and 0.8. And they'll be randomly selected, so that there's thousands of comparisons, but we'll randomly select some and have the SMEs review those. Another task we're planning to do this year is we're going to sort of do a shadow analysis on the 2025 form assembly. And so what that means is we'll take a look at the first draft of operational forms and then compare them to the second draft, as well as the third drafts if there are any, to see what the similarity values were for the initial items, compare them to the replacements, noting what the item pair values were that were replaced, trying to see what those values come out as. And then we'll also compare the 90th percentile similarity values of the 2024 forms with the 2025 operational forms. And our goal with this is to find a cosine similarity index threshold for efficient form assembly. And by that, we mean that if we're to run the program on a set of items that fits our test specifications for the exam, and then there are item pairs where the similarity values are over a certain value, then the form assembly team would proactively rerun the form building program to replace them before sending them to the SMEs. The intention of this is to reduce the number of back and forth between the SMEs and requests for replacements, to reduce the time it takes, the effort involved, and preserve the SME time. Next slide, please. And in summary, the proof of concept has very encouraging results. Currently, we focused on just 2 sections of the exam. We may look into the BBLS section as well. We found a high correlation between what the AI found and the human enemy and friend identification between the two, showing that it seems to be working in identifying what it's meant to identify. And then we'll work towards identifying a cosine similarity index threshold for efficient form assembly, which I might mention, it could be different between sections depending on the data we find amongst the different sections. We'll treat them separately. And then I think Gary is going to give a demo or example of what the program looks like. Thanks.
Thank you, Erica.
Let me share my screen here. Let me know if you guys can you see my screen?
You can, Gary, go ahead.
All right, great. So in Pro, we have, as Rory mentioned, we have this concept of a pool book, and then we also obviously have a concept of a form that's in there. And you can kick off the enemy analysis in either way. If it's for a form, it's just for all the items that are in that form, or if it's for a pool book, it's one or more items that are in the pool book. I happen to have them all here. This is just some sample items that I have in our demo environment. And you can see some have passages in here. Other ones just have discrete items that are in here as well. So on the bottom left, there's a few options you can do on pool books. I selected enemy analysis and clicked execute here. And what shows up is this dialog. And so what Pro has done, it's gone through, it's looked at all the items that are selected for this analysis. And it's looked to see if there's any passages and or discrete items in there. If there are no passages, these passage options will be disabled for you. So it's smart enough to know that, so that way you're not just going to be selecting those, but there's no passages in there. So we also support some advanced settings. So this goes to show what Rory had talked about. Do you want to do passage to passage, passage to passage item? Do I want to skip items that are in the shared passage as well? Do I want to include non-key options as well? By default, we just include the key, the option that is the key. And I'll do some discrete items here. In the advanced mode, you can select a different model. So we have two here, two models that we have that you can select through. If there are additional models, very easy for us to deploy another model to the server, and it would show up here for selection. And then you would just click create report. So what it's doing now is it's taking all the content from all those items and passages that are there, and then sending them up to our science server, secure science server. And depending upon how it's set up, I think this demo environment is still a CPU, but we have a GPU available as well. And if I go back and click on this is our process status that refreshes every 30 seconds. You can see it was already completed. If I click in a couple of these, you can see, this may be a little bit small for you guys to see, but it shows you all the different settings that you selected, so you can see that. And then you can download the results. So let me show you the results that are downloaded here. And so in this spreadsheet, let me just open these up so you can see these a little bit more. In spreadsheet, you can see we had three different comparison types to what I selected: passage to passage, passage to a passage item, or a discrete item to a discrete item. And then it'll tell you the pool book that it was in, mainly because although this is just one pool book, if you're doing a form, there could be spread across multiple pool books that are in there. But you can see here's the name of the passage, and it did passage 1 to passage 2. And this is an exact duplicate because in my data, I really just cloned that passage that was in there to be able to show you that. But you can see there's some other ones that are middle of the road type comparisons that are in here. And, based on what Erica was saying, they would look here for their threshold to be able to pull out those items, to be able to actually bring up those items in Pro, take a look at those and see if they are truly friends or enemies that are in there. So right now, this is going to give you the scores associated with those. And eventually, like Erica said, there's going to be some threshold that we can also add functionality in the Pro that would alert those items in the threshold that would key them to be able to look at those as well. And so you can see down here, there's some that are completely dissimilar as well that are in here. So I just threw some items that were in there that didn't have anything to do with any other items, just to be able to show you how dissimilar that they are in here as well. Okay. So that's what I had to show.
Thank you, Gary. Just a quick reminder for those on the webinar, if you do have questions, go ahead and plug those into the Q&A function that should be visible on the bottom. And I'll be monitoring that to answer any questions as we go through. So with that said, then we're going to transition to talking about exam review or exam form assembly, as well as form review. And just to start from the very beginning, as it were, wanted to turn it over to Susan to just talk about the process of exam assembly and form review, as well as some of the pros and cons to how it's being done right now.
Yeah, thanks, Rory. So I'm sure some of you on this call have been through this process before in some form where you've done exam assembly. Marc just talked about a very complex system with the number of forms that they're developing. It can be quite a huge task. It is putting together a big puzzle, and you probably have way more pieces than you need, and you have to figure out which pieces you're going to use. It is a huge puzzle. So obviously the goal is to build strong forms for your operational test administration that meet all the specifications. And you want to make sure you're using the depth and breadth of your item bank. You don't want to say, oh, that item looks good, let's use it, without considering how frequently it's been used in, say, the past 2 or 3 years. And where this gets more complex is that we're building more and more complex test specifications. So depending on the program, you might have content specs, like how it maps your content outline, cognitive level, item type, the type or number of different stimulus materials that you use, item difficulty. You might have a target average or maybe a target distribution, item discrimination. You might have specifications around previous use. And that's just for a given form. Then you have to think about the overlap between forms or among forms if you're doing more than 2. How many items are overlapping? What's that content distribution look like? What item types are in there? What's the difficulty? What's the discrimination? And then all doing that while avoiding those enemies and variants that everyone was just talking about. That's why my eyes lit up. Like not have to think too much about that would be great, or to have the system account for that is just, I love that formula. So all of that it's a lot. And the process really is kind of like Marc described, where a draft is created, it's then reviewed, checked for content. Is this content still current? We look for variants, we look for enemies, then we have to go back and revise. We have to review those replacements or review the whole thing again. And it can go multiple times around. So it's kind of it's a tough process to go through. So there's different options out there for doing this. Sometimes these are assembled manually, again, just depending on the nature of the program. Sometimes there are systems in place to help build a first draft. Obviously, the manual process, you can meet the specifications because you're working at it yourself. But you may not be great about maximizing really the use of your item bank there, and it can be very time intensive. Some of the the computer-based tools now that we have to do that, or that have been out there, can help you really with 1 or 2 of those dimensions I mentioned, but there's a lot more dimensions that we want to be able to consider to really, again, create great forms and make the most of this valuable resource we have, which is the item bank. So some of the goals for those automated tools is to really get it integrated with the item banking system so it's all secure. You're not moving your items around or your content information around. Create a draft solution that can be reviewed and modified if needed, and really can accommodate different types of specifications. So, like, again, with the number of programs we work with, it seems like every set of assembly specs is different in terms of what a group is considering and how specific they are, just based on the strength of their item bank. So we had lots of hopes and excitement for this, which we were excited to get to partner with Strasz to try out their new tools.
Thanks, Susan. So wanted to start with just some of the background in automated test assembly, because this is not a new topic. A lot like enemy item analysis, has been a subject that's gone around in terms of comparisons for over a decade and a half. Similarly, automated test assembly has been around as a concept going back about 2 decades. Just wanted to provide a quick quote here that I picked up from some of the literature just on defining what automated test assembly is. But at its core, we're talking about a couple functions. One is the use of a linear processing engine to be able to meet the varied constraints. As Susan mentioned, that can be minimal, that can be extensive. And increasingly, we're seeing more and more extensive and complex with regard to both specifications as well as other constraints. The other aspect of it, of course, is the enemy item identification piece, which we've covered already, and again, incorporating that into the process. So interestingly, a lot of the research on automated test assembly that I identified really goes back to the mid-2000s and into the mid-2010s. And I found ample literature, in this area that largely seemed to die down a bit when we started seeing the massive influx of pool-based delivery approaches. As more and more organizations moved to, say, loft delivery or CAT delivery, we saw quite a bit of decrease in the academic research in this area. And indeed, again, the emphasis that you can find in these articles and presentations truly does kind of work hand in glove with some of those early psychometric thinking around pool-based delivery approaches. And further, this isn't Straz's first ring around here on this subject. Indeed, we have some past experience building a custom automated test assembly engine as part of custom development work. And so really that supported the desire to look at something that could be built out with broader scale and broader options for credentialing organizations. Because at the end of the day, while there's certainly been a lot of organizations moving to pool-based delivery approaches, there are still quite a few that continue to use set forms. And indeed, we've seen some organizations moving back to set forms from pool-based for various reasons, whether it be specific forms call out for certain usage, that complexity of specification and constraints causing it to be difficult to meet via pool-based delivery approaches, etc. So with the research that's going on these days in this area, and as I said, it's slowed down quite a bit, but just a couple points to bring out from the limited literature review that I'm mentioning here. Number one, there's been past research actually comparing automatically assembled test forms with those done manually by psychometricians. And you can see the references here for those. Secondly, a lot of the recent research in this area has really looked at altering, let's say, off-the-shelf technology to do this. And in fact, while I'm listing the one here for SAS, I found mentions of adapting code within SPSS or other types of platforms to fulfill this need. And finally, interesting to note that one of the uses of automated test assembly was actually done to really look at optimal form length and utilizing this as a tool to make that process of identifying the optimal form length a lot more efficient with, again, a national medical exam. So all that said, what did we do to really put this together and get our product live? A couple things. So first off, as we went into the conceptualization of this, it was really important for us that the average user, the user we had in mind, was not necessarily, with all respect to my colleagues on the call, it wasn't necessarily Susan or Marc or Erica, to be somebody who had a more lower level experience, just based upon our experiences seeing a lot of times the first draft of a form being put together by a test developer. A lot of times that person not necessarily having a broad psychometric background, but good learning on the job experience to bring into that process. Number two, configurability was really central to us as well. As you heard Susan talk about, the variance that we encountered even within our piloting work was astounding, both with regard to the blueprints, multiple blueprints, types of blueprints, the level that the blueprint went down. I could go on, you get the idea. The statistical model used, all of these things needed to be options such that the platform could meet the requirements of, let's say, 95% of the average organizations doing form assembly. Integration ready, we established this as I've called it, middleware. So it is integrated with and appended to our item banking system. But we also felt that it was important for our partners, as well as individuals that we work with, that it be integratable into other platforms by API. At the end of the day, we wanted to make sure it was transparent. We're not assuring via this process that the final result is indeed ready for prime time. That's certainly our hope. But we do believe that this is important to still have human at the center, as we do with all of our AI development and such. In that vein, it's important that the results and the draft forms be clear back to the user, such that that can be either adapted or used as initially developed. And then finally, scalable and iterative in nature, as we've talked about with the enemy item identification. These processes do put a big load on infrastructure. So it was important for us that be scalable both from a software standpoint and hardware standpoint. And then finally, that we're going to continue to add on aspects to this platform. So at ICE, we launched the initial offering here, but indeed are looking already at the next set of changes and additions that we might make. So with all that said, we piloted this. It was important to us to ensure that we also got feedback along the way, and indeed, many thanks to Susan and ACS, because they were our fantastic pilot partners on this one. We did run multiple iterations to validate the software, and our initial focus was on classical test theory. Not that IRT was out of the question, but we wanted to again simplify some of our initial pilots, and also trying to ensure that there were certain types of let's say constraining factors that weren't present in the initial examples that we went through. What did we find? Well, we were able to meet the blueprint in every pilot example, which was fantastic. The CTT parameters, when those were run, were able to be met within 0.02, which again was a great result, given that at least from my brain, typically we're trying to target within 0.05 for ease of equating. The thing that we found certainly that required the most adaptation was overlap. And the overlap parameters were those that really drove whether we would get a result within 30 seconds or whether it took 3 to 5 minutes. And it also identified some more options that we needed to add, which again, we've done here in this next iteration. I want to just go over to Susan and just have her talk about some of the work that we did in the pilot and things that she identified as we went through this process.
Yeah, thanks, Rory. And I like how you kind of framed your time frame in minutes, where I was thinking for if it was a manual process, it would be hours. So I'm like anywhere in the span of minutes. Yes, we greatly got to benefit from all the hard work they did, and by being the guinea pigs here, we got to come in and test out this technology, and absolutely beneficial in terms of, again, just first of all, the workload, the time that was able to produce the results that we could look at and evaluate was fantastic. And we did do a manual process on the back end just to see what would it be. And again, the biggest comparison was time, but then we also did compare how did we meet the specs, and it was meeting the specs. The programs we piloted with Strasz were very different in terms of what they were looking for in terms of forms assembly, overlap, characteristics, all of that. And as he said, you know, it got tough. Even the same challenges that they probably were seeing were the same ones that took us longer manually. Is like, we could build great forms, but if the overlap didn't look exactly like what was intended, you had to go back and revise. So yes, the forms that it produced met our expectations. We could go in and make those minor tweaks. We could look for the variants and the enemies. But again, overall reduced our time significantly to make this happen.
Appreciate that, Susan. And I'll also mention, as part of this process, we also identified the need to move to a different linear programming solver, just because of the processing time, which again is what we've done for the release. And so, cognizant on time and with a couple pending questions here, I'm going to turn it over to Gary in just a minute, but we did indeed, as mentioned, launch this at ICE. With a set of features that you can see here. We're going to go over those in just a minute, so I won't belabor the points, but I think it's also important to point out that, as mentioned, you know, this is going to be something that continues to evolve. We'll be looking at adding quite in the near future, finalizing the integration with the dynamic enemy item identification that we just showed you a minute ago. Also adding in things like item exposure parameters. So, you know, don't add in an item to a form if it's been exposed more than X number of times. We've also looked at balancing time spent on an item, so median time, and looking at balancing those between forms for those organizations that track time per item. This is especially useful for organizations with shorter exams, such as more common in the IT certification sector. And then also additional configuration to control prioritization. That is, by default, you know, the blueprint kind of becomes sacrosanct, the statistical targets next, and then the litany of other configuration options, you know, kind of come in after that from a prioritization standpoint. We want to give users more control over where you're weighting items and how important various aspects are to you, as you seek to get the best draft of these forms. And then finally, doing some additional integration aspects that, again, will allow for seamless use by both our pro users as well as users of other item banking systems. So for purposes of time, again, just reminding you the Q&A function, but I'm going to stop sharing, allow Gary to give you this quick demo before we get those questions answered and adjourn. Gary?
Okay, great. Can you see my screen?
Sure can.
Great. Okay, so a user will come in here, and right now this is connected to our Pro item bank through APIs, as Rory was saying, and we have that concept of a pool book. So you can select a list of items from a pool book that you have available, excuse me, and select those. We also have, as I'm going to go through here, I'm going to select a template first, so you can put all your information in here and save them off as a reusable template. So just for the sake of time here, I'm going to pull one of these templates up. And you can see it already pulled up this pool book from Pro. It also looked at all the items that were in there and dug out all the different specifications that were associated with those items and puts them in the list here. In this case, we just selected meds. We also support entering in counts of at 2 levels down for second levels. So you can see in here, and you can drill down here and put your counts in there. For the sake of the demo, they're all at the top level. And for the first 10 areas in the specification, you know, we targeted 10 items for each one of those. We do support adding a second classification. That second classification would just be at a single level that you could also supply counts for as well. And then you come down, you just fill out this form, you give it the base name of what we're going to create, how many forms you want, how many operational items you'd like to have. In this case, I don't have pre-test items set up, but you would specify N number of operational, N number of pretest items, and then out of that, how many would be single selection or how many would be multiple selection items. And as Rory had alluded to, some of the things we're going to be doing in the future is allow folks to define these as well. So that way if they have, 10 different item types in there, they could specify those as well. And then you select the assembly theory you'd like, whether you want classical or IRT. We support both in there. But you would specify your mean p-value target and then the R-biserials in there. When it actually goes and works, it'll try its best to get to 0.4, but it may look at 0.05 in either direction as it's coming through. And then here's the overlap that Rory was talking about. Here's for 0 and 10 for this. The similarity cutoff is going to be future. So as we add the ability to integrate in, you'll be able to put the actual cutoff that like Erica was talking about in there as well. And so I click build, and what it's doing now is it's taking all the parameters from all those 100 items. I'm sorry, 1,000 items in there. It's sending them over and marshaling over to the optimizer. Really, by now the optimizer is probably done. It's kind of like it only takes like less than a second to be able to do that. But it's really the marshaling of the data back and forth. And so now the data is coming back, and we're creating a presentation to be able to show you here. So quickly, you can see on the left, if it's all green, it's good, it met your specifications. That's in there. If there was something that didn't meet, it would be red. You can click into details here to be able to see that, to see if it was able to meet those all or not. It provides a nice item quality chart, so you can see the nice scatter chart that's in there. And we have an emulation chart here as well to see how well it would perform. And so you can see here we have Form 1 and Form 2 that's in there. And we're kind of running out of time here. So let me just show you the Excel file that gets sent out. So here's the output as well. So you can see here from a forms parameter has all the items in there, has all the data that we used, whether or not it was selected in Form 1 or Form 2. It'll give you the average p-values and R-bis that are in here. And if I click on the forms, this actually is just all the items and if it was used and what form it was used in. Real quick, we do have a chat assistant here as well. So you could ask it some information. You could just say, show me a bar chart of the data for Form 2. And it'll go off and since I didn't really ask it anything specific about it, it'll go off and try to figure out what it wants to be able to do there. But you can ask it some information and it'll go off and do its thing and come back and show you the chart. And then also you can email it out to yourself. We'll be looking to move this out into a further enhancements and move forward with that. So I know I'm out of time, so I'll just.
Oh, no worries, Gary. While you pull that up and show that, I do want to just get one question here answered, and in the well, since we're over time here, Marc and Erica, just curious as to your thoughts. The question was dying to know if AAMC has an estimate of how many hours this might save for SMEs. So
the short answer at this moment is no. But as Erica mentioned, we do have that kind of form assembly shadow analysis plan for 2025. We can kind of see, how well this method would have done if applied to the forms that we are currently assembling. That could give us a sense of reduction of iterations. And also as we, further learn about what's going to be a good threshold for us. The quality of that threshold will also inform this. So don't have an answer today on that, but our future work hopefully will inform what level of SME hours savings we can get to.
Appreciate that, Marc. I know we are over time and want to be respectful of everyone's time, especially on a Friday. So we look forward to providing an update in future months. We'll not only hopefully have more news to share from the continued evolution of enemy items with Marc, but also are excited to see the results of a final pilot that we're doing where we're actually live in field with automated assembled forms. Versus some manually assembled forms, and to provide those results out. So with that said, I hope everyone has a wonderful rest of your Friday. Many thanks to my fellow speakers here for their time and preparation, as well as continued collaboration and partnership. We're very appreciative. And for everyone who joined, we hope you have a great weekend. Look forward to talking to you soon. Take care now.